It says, prove that 4 to the power of n plus 14 is a multiple of 6 for n is greater or equal to 1 by induction. Okay, so we're going to show that this is a multiple of 6. It's divisible by 6. So I'm going to start with our usual step 1. We're going to show it's true for n equals to 1 because it starts from 1, doesn't it? So we're going to show that it's true for n equals to 1 by subbing in 1, just like this. Okay, and you know that 4 plus 14 is simply 18. Now, for our simplify that, it's going to be 6 times 3. 18 is a multiple of 6 because we know that 18 is 6 times 3. So therefore, we can just say it's a multiple of 6. Okay, so we've shown step 1. It's true for n equals to 1. Always make a conclusion. You can start step 2, the assumption. Assume that statement is true for n equals to k. Replace n with k, like this. 4 to the power of k plus 14 is divisible by 6. So I'm going to make that 6 times some integer p. 6 times p is a number that's multiple of 6, isn't it? So I'm going to let that be 6p and make sure p is going to be an integer. So that's step 2, that's our assumption. Now step 3, show that the statement is true for n equals to k plus 1, and just note that there's the assumption, okay? And we'll use all this space for step 3. I'm going to replace n with k plus 1 this time. We want to show that 4 to the power of k plus 1 plus 14 is a multiple of 6, or is divisible by 6. So it's going to also be 6 times some number or some integer. This time I'm going to use q. This must also be divisible by 6, so it's equal to 6q for some integers q. I'm going to show that left-hand side is this first of all. What I'll do is separate out the 4 to the power of k plus 1 like this, because I know that 4 to the power of k plus 1 is 4 to the power of k times 4 to the power of 1, isn't it? Because we add the indices to get to there. So I've separated it out like that. You can see that 6p minus 14 is 4 to the power of k, because see from our assumption, if I make 4 to the power of k the subject, by moving 14 over to the other side, that will be 6p minus 14. So that's replaced 4 to the power of k with 6p minus 14. Now, because I want to always utilize my assumption into my step 3, because then we can get to the final answer. So I've done that. Let's do a bit of expansion. We know that 4 times 6p is 24p. 4 times negative 14 plus 14 will be negative 42. This is just some easy calculation, just expand and simplify. Because we want to show that it's divisible by 6, so we want it to be 6 times some number, I'm going to factorize this by 6 and see if it works out. Okay, I factorized by 6. The inside is 4p minus 7. Okay, so therefore it's a 6q, and q is going to be this part here. So it's 6 times q, which is what we wanted, wasn't it? That is the right hand side, so we've proved for the step 3 when n equals to k plus 1. So therefore always make a conclusion in your induction. Therefore 4n plus 14, which was the original question, is divisible by 6 for all n is greater than 1 by mathematical induction. And that's pretty much it. Okay, so again, always remember to give yourself a little conclusion.